Imagine a point of unimaginable density, smaller than a single atom, containing the blueprint for everything we see today. Suddenly an explosion, a burst of energy unlike any other, marking the birth of our universe. In the beginning, there was nothing. And then, from this inconceivable void, came the singularity. Picture all the energy of the universe compressed into a point infinitesimally small, a point of infinite density and temperature. Then, imagine that point exploding with unimaginable force, birthing space and time. This was the Big Bang. As the universe expanded and cooled, energy began to coalesce, forming the very first particles, the building blocks of everything we see around us. Imagine a vast, swirling cloud of hydrogen and helium, remnants of the Big Bang spread across the universe. Gravity began to draw these gases together, pulling them into dense clumps. The pressure at the center of these collapsing clouds became immense, so intense that hydrogen atoms began to fuse, releasing unimaginable amounts of energy. This is the moment a star is born. These first stars illuminated the early universe, their light piercing the darkness that had reigned for millions of years. Now let's turn our attention to the stars, these magnificent balls of plasma that illuminate the cosmos. Their lives are a delicate dance between gravity and the outward pressure from nuclear fusion at their cores. Smaller stars like our own sun burn steadily for billions of years, nurturing life on any planets fortunate enough to orbit them. But larger stars live fast and die young, culminating in spectacular supernova explosions. These explosions scatter the elements forged in the star's core across the cosmos, seeding the universe with the ingredients for new stars, planets, and even life. Deep within the heart of a star, under unimaginable pressure and heat, a cosmic alchemy is at work. This process, known as nuclear fusion, is the engine that powers stars and creates the building blocks of the universe. In the core of these celestial giants, temperatures soar to millions of degrees, and atoms collide with such force that they merge together, forming new elements. It's a process that has been ongoing for billions of years, shaping the very fabric of our existence. The carbon in our bodies, the oxygen we breathe, the iron in our blood, all forged billions of years ago in the nuclear furnaces of stars. These elements are the fundamental building blocks of life, and they were created in the hearts of ancient stars. As stars age, they go through various stages of fusion, creating heavier and heavier elements. This stellar alchemy is responsible for the diversity of elements we find in the universe today. Through nuclear fusion, stars fuse hydrogen into helium, helium into carbon, and so on, creating heavier and heavier elements. This process is not only crucial for the life cycle of stars, but also for the creation of the elements that make up planets, moons, and even life itself. Without this continuous fusion process, the universe would be a very different place, lacking the rich variety of elements that we see today. Each stage of this stellar alchemy releases energy, the very energy that makes stars shine. This energy travels across the cosmos, illuminating the night sky and providing the warmth necessary for life on planets like Earth. The light from these stars can travel for millions of years before reaching our eyes, a testament to the incredible distances and timescales involved in the universe. And when massive stars reach the end of their lives, they explode as supernovae, scattering these newly formed elements across the cosmos. These spectacular explosions are not just the end of a star's life, but also the beginning of new possibilities. The elements scattered by supernova seed new star systems, planets, and eventually, life. This cosmic recycling ensures that the universe remains dynamic and ever-changing, with new stars and planets forming from the remnants of old ones. It's a beautiful cycle of creation and destruction, one that has been ongoing for billions of years and will continue for billions more. Now let's zoom out and consider the grander structures of the universe, the galaxies, these vast islands of stars, gas, dust, and dark matter. Their formation is a story of gravity, sculpting swirling clouds of primordial gas into the majestic structures we see today. Over eons, gravity drew these clouds together, pulling them into dense clumps. These massive rotating clouds of gas and dust became the birthplaces of stars, millions upon millions of them. As these stars ignited, their combined gravity pulled the surrounding material into a spinning disk, giving birth to the spiral galaxies we see today. In the vast expanse of the cosmos, nestled within the Milky Way galaxy, lies a rather unremarkable star, our Sun. Orbiting this star is a collection of planets, moons, asteroids, and comets, our solar system, and on a small rocky planet, the third from the Sun, life, as we know it, exists. We are a product of the universe, formed from the very elements forged in the hearts of stars that lived and died billions of years ago. From a simple beginning to a complex present, the universe continues to expand and evolve, and so does our understanding of it. As we explore the cosmos, peering deeper into space and time, we unveil more of its secrets, unraveling the mysteries of its past and present. Our journey through the cosmos has just begun.